Welcome back. We are going to talk about something called the constant of proportionality. And, surprise, you've basically already been doing this, just haven't been putting like the fancy mathematical name on it. So, our I can statement is I can, scooch down a little bit, find the constant of proportionality we'll leave it there. Okay, so this is really just an extension of unit rate. Okay. So the constant of proportionality is the unit rate from the ratio of y to x. And let's pause for a second and think about, what does this word constant mean? Okay. So something that's constant is something that's ongoing, happens over and over, repeats, or is the same. So what this is saying is that the unit rate, right, if I'm driving a car, I go 60 miles an hour, okay, that's 60 miles per hour. Well, 120 miles in 2 hours, that's the same rate, right? That has the same unit rate, but they're different numbers, okay? And so we get this by taking y divided by x. So kind of when we were checking for proportionality, seeing if tables were proportional, okay? So this situation says a phone company charges $22.50 for every 3 additional gigabytes of data used. Okay. So our constant of proportionality, just our unit rate, is represented with the letter K because we're already using C for something else. And it comes from taking thing Y divided by whatever X is. But you don't necessarily need those, right? If it's $22.50 for 3 gigabytes, I want to find the cost per gigabyte. So I'm going to take the cost, $22.50, divide by the number of gigabytes, 3. Okay, and this turns out to be $7.50 per gigabyte. And we can use a table to fill that out. So for 3 gigabytes, my problem tells me that's $22.50. Okay, and we just found out the cost per gigabyte, so the cost for 1 gigabyte was $7.50. And then to get the other ones, I know that my first thing, the dollars, comes from my unit rate, my constant of proportionality, times my second thing, the number of gigabytes. I'm just going to abbreviate that. I don't feel like writing the whole word. Okay? So my dollars comes from taking the gigabytes times my constant of proportionality. So 2 times 750 is 15. So it'll cost $15 for 2 extra gigabytes. Okay. Then again, using my unit rate, the first unit, the cost, comes from my unit rate, or my constant of proportionality, times the number of gigabytes. So if I take the number of gigabytes 0 times my unit rate, that will give me my cost. And anything times 0 is 0, right? It's not going to cost us extra money if we're not buying the extra things. Okay? All right, the next one from the table, it shows us the cost of vanilla flavoring, and we want to find the unit rate, the cost per ounce. So my constant of proportionality is just that unit rate, and in a little bit, in a couple lessons, we'll talk about why does it have to be a constant. But for now, it's basically just a way to label the unit rate and how to use it to find missing information. Okay, so that constant comes from the cost per ounce. So I'm going to take one of the 2 points where I have both the cost and the ounces. And let's do this one for funsies. So I'm going to take the cost, 250, and divide by the number of ounces, half an ounce, 0.5. So my unit rate, or my constant of proportionality, is 250 divided by 0.5. And this ends up being $5 per ounce. And so where that constant of proportionality comes from is that I'm multiplying by the same thing every time, right? It's constant. It's happening every time. So my cost comes from my unit rate times the number of ounces, right? So that first thing times the unit comes from the unit rate times the second unit. So my cost comes from the number of ounces times $5 per ounce. 0 times 5 is 5. Okay. Then, just to check it, my cost comes from the number of ounces times the unit rate. 0.2, oh, there it is. 0.2 times 5 is 1. And then just to double check my work, okay, 0.5 times 5 is indeed 250. So I know that since I'm going the same direction, I can still multiply by 5. And 3 times 5 is going to be $15 for 3 ounces of vanilla flavoring. Okay. So these, our unit rate is the constant of proportionality. Okay? All right, so last one. So the graph shows the relationship between the number of cupcakes decorated and the number of minutes. Okay, so after 0 minutes, and we know it's proportional because it's a straight line through the origin, after 0 minutes, 0 cupcakes have been decorated. Okay, and let's write this down so we don't forget. Points are always x, comma, y. Okay, so this is your x-axis on the side, and your y-axis goes up and down. Okay, so then after 2 minutes, my x is 2. I'm going to go up to find the y. Okay, after 2 minutes, 8 cupcakes were decorated. And then I don't have 5.5 on the graph. I don't have 48 on the graph. It doesn't fit on the graph. So I can use my constant of proportionality. So my constant of proportionality, or my unit rate, comes from y divided by x. So I'm going to pick a y. We'll have to use 2/8. Okay? So let me get a highlighter. So the y value is 8 divided by the x value, which is 2. And then 8 divided by 2 is 4. So our constant of proportionality is 4 cupcakes per minute. Okay, so to use that, so the number of cupcakes, my first unit, comes from my unit rate, 4, times my second unit, the number of minutes. And these tables are flipped. Okay, so the number of cupcakes, this blank spot, comes from my number of minutes times 4. So 4 cupcakes per minute times 5.5 minutes is 22 cupcakes decorated in that time. But look at this one. This one's flipped. What do you think I should do to go the opposite direction? If I go the opposite direction, I'm going to do the opposite operation. So if I divide this by 4, that will give me the number of minutes. And 48 divided by 4 is 12. So the constant of proportionality is just the unit rate. We note it with a letter K. So go back up to the top. We'll say this is the constant of proportionality. And remind yourself that fraction bars are just division problems. So y divided by x, it's your unit rate, and you can use that to solve problems, find missing values, or predict what's coming next.